why or what is custom paint to start with? Custom paint is a method to achieve in Flutter what the system does, what the Flutter framework does. So to put it simpler, I don't know how far into Flutter you guys have gone, but there is a system of abstraction in Flutter, from the widgets to the elements tree to the render objects, as per what is provided, what Flutter provides us to actually create widgets on our screen, to create UI, user interfaces on our screen. Now, in as much as render objects are really powerful, elements are really powerful, widgets also in itself, they are quite comprehensive. What custom paint is doing is that it's allowing us to bypass all of that layer and go straight to the rendering. So we don't need to manipulate elements, we don't need to manipulate render objects, we just go straight to the painting. So when I say draw a container, let me see if I can stabilize my monitor connection. Okay, so when I say draw a container of height sorry, give me a minute. I guess I'm going to have to back at this. Okay, so when I say draw a container, are you guys still with me? I'm going to have to assume that you guys are still with me. And with 200, with a color, let's say color green. What I'm doing, let's look at this paint. Okay, so when the app finishes rebuilding, we'll actually see what that's going to show on the screen. But I'm pretty sure we're all familiar with what is going to happen. We're going to have a container with height 200 and width 200. Now, what we are telling Flutter to do is that we're saying take a offset from the top of the screen, right? From the top of the screen, draw 200 pixels to the right, 200 pixels downward, and fill that with a green color. And now the widget takes the configuration of that, sends this down to the element to the structure, and then the render objects now takes that and then renders it on the screen, right? And then so that's when you rebuild and reload, since the element already has a structure, there's really a lot of optimization going on there, so there's no much efficiency wasted. And okay, yeah, so we have this is like a column, that's why it's like that. Let me remove this custom paint for now. And yes, so we have this 200 by 200 rectangle, or rather a square, on our screen. And this right here, this rectangle 200 by 200 is being painted on the screen via a much abstracted version of custom paint under the hood. So under the hood, render object, what render object is doing is that it's saying 200 fill with green. And if you're actually interested in seeing it in action, we could go really far into the into the configuration of container and see that happening, see that in action, but I don't think we have the time to do that. You could do that on your own, and I strongly recommend you do that. It's one of the most efficient ways to actually learn in Flutter, by going inside the code to see what's going on inside there. And so what CustomPaint is now, CustomPaint is the mechanism by which we as developers are able to access the core mechanism by which Flutter uses to paint on the screen ourselves without passing through all of that strenuous layer of widgets, elements, and render objects. So CustomPaint is really, really, really powerful. It's really, really useful. It's also very efficient and very easy to cause problems since it's giving you access to the bare metal tools. Now, maybe asking, okay, there is widgets, there is elements, there's render objects, there's all of these incredibly powerful things that allows us to do this complex stuff such as text. I mean, these same CustomPaint, when I say text, I am a Nigerian. Right, Nigerian. And I render this on the screen. What is actually happening is that I am a Nigerian. What Flutter is doing is that it's taking the configuration of the font and using that to use CustomPaint to paint I, to paint A, to paint M. And so that should give you an idea of how incredibly powerful CustomPaint is, that you can use it to do something as complex under the hood, as complex as actually writing text of any font size, any font family rather, any font configuration. This is CustomPaint that's doing this. This is Paint, the painting under the hood, the text painter. And we can actually make use of this by ourselves. So you may be asking, okay, great, this is all good, well and good, it sounds amazing, it's powerful. Why do I need to use it? What do I need it for? And that's a very, very nice point to consider. It's not every time that we need to use CustomPaint. In fact, for me, I use CustomPaint very, 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 very rarely, only on unique projects that require some level of fine detail, such as, say, painting, having users be able to draw on their screen. Right, that's one very, 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 very good use of CustomPaint, the combination of CustomPaint and gestures in Flutter. So there are other examples of use cases of CustomPaint, such as, let's say you want to build custom complex UIs, or you want to perform manipulations on things that Flutter's general widget library doesn't provide. If you have been in the Flutter community for a while, you would know that there has been some, I would call it a revolt against the material library, since material library is not powerful enough, it's not complete enough, doesn't have enough toolkit, and the toolkit that they provide doesn't provide enough configuration for the general use cases that some people might want. So you have stuff like the Cupertino library. To supplement that, you have stuff like the there's Fluent UI for Windows, and there is a recent one that ShadeCN, I think. ShadeCN. It's a new UI library that tends to be more consistent and manipulatable than Material. Now, why am I saying all of this? What Flutter is providing to us sometimes is not sufficient, and sometimes we have to go outside the box to perform our own magic to get what we're looking for. So that said, that's the reason why we would want to use CustomPaint. Let's dive into the details. So to be able to custom paint as a verb, we need two things. We need the CustomPaint widget that gives us direct access to the canvas, right? So what this CustomPaint widget is doing is that we're going to pass it a size constraint for our screen, and let me just give this big enough space and then wrap it the container so it has background color. Right. Okay. Okay, let's give this to simple size. Okay, great. So we have a 400 by 400 container. Oh, sorry, 400 by 400 area of the canvas for provided for us to paint in. Now, what this CustomPaint widget is doing is that providing us a canvas, and then now for us to actually do the actual paint manipulation, for us to actually do the magic, we're going to need a painter. So, and I'm going to do that in a separate file just to keep everything concise. I'm going to call that, let's say, my painter or my custom painter, and it's going to extend custom painter. If you guys can't hear me at any point in time, please do well to let me know. Now, custom painter has two methods for us to override: the paint method and the should repaint method. The paint method is where all the magic happens, the beautiful fun magic. And then the should repaint method, we're going to come back to that in a bit. For now, we're just going to return false. And I'm going to come back to why we need all of these covariance, custom data, old delegates, blah, 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 blah. All of this stuff later. So let me just put that down. Okay. So now we need to come back to our custom paint widget and pass in our custom newly created custom painter. And okay, it's not comes. And just like that, we have done all the necessary configurations required for custom painting. The next step is to do the thing. Okay, so now in custom paint, while we are painting, there are okay. Let me remove this code by the suggestion. There are a couple of things that we need to consider. Remember the size that we set here, this 400 by 400. Now that size is what's going to be passed in here, and it's also configuration for our canvas. So what we are doing is that okay, this paint method is allowing us to tell Flutter that relative to this canvas that you're providing to me, I'm going to paint whatsoever it is I want, whether it's a text or a rectangle or a circle or something as complex as a human face. Great. So let's get into the simple tools that we can do, simple operations that we can do. Custom paint, here a couple of things. We can draw a line where we have lines, we have circles, and we have rectangles, arcs. We have path, and then there are arcs that we can work with. But arcs are a bit advanced. There are also stuff like Bezier, curves, etc. Those are a bit more advanced. I would encourage you to look into it on your own, although it can be quite daunting, but I assure you it is fun. So let's start with lines. So these are basic shapes, basic geometries that we usually would want to manipulate to get what we are looking for. To draw a line in custom paint, we need two things. We need a paint variable. So I'm just going to call it paint. Now we're going to set the color to paint, and we're going to set a width. Okay, now what paint is, we are seeing paint here, You might be wondering, okay, this is getting confusing, what's going on here? In order to paint on a canvas, what constitutes the entire structure we are looking for are geometries, right? Every single thing that you're seeing in this screen, this debug flag here, this is a geometry. It's like a configuration for it. There is an angle that is slanting at, I think that's 45 degrees. There is a width for this stroke. There is a text that has a letter spacing, etc., etc. configurations. Now, in order to bring those configurations to life, to provide it with color, we use this paint widget. So just like in a container, you would say, if I remove this color to gray, right, and then there was no size, if I remove this color to gray, nothing would show. But in order to provide character to it or provide decoration to it, I put color, and then I can do some other manipulation by adding a border, adding a round a border radius, etc., etc., etc. All of those things are what paint does. And then the actual configuration, like in container, we can set a padding, a margin, a constraint for max and minimum width, etc., etc., etc. All of that is what these lines and circles and rectangles are. So this paint widget is this paint variable is very, very, very important. It's very, very required for us to actually provide decoration to our configuration. Now, the next thing we're going to do, since we have the decorator, we're going to create our configuration. So let's just say this brings life to our desired configuration. I hope this makes sense. If you have any questions, you can always stop me at any time and ask a question. So next thing we're going to do is to do our configuration right now. How do we do that? We're going to use canvas. So the first step is to draw a line, right? We're going to try to see what we can do with a line. Okay. So I think I should disable Copilot suggestion. So this is disturbing. Okay, so draw canvas or draw line. Now, if you remember in mathematics, they said a line is the distance between 2 points, right, in a plane. That same analogy is what Flutter is using. Flutter is giving us to use. So we need 2 points: the start point of one line and the end point of that same line. So let's just set the first point of our line to be size. Okay, it's an offset for the point, and we're going to set the horizontal offset. Now, if you're not familiar with all of these things, let me try to explain it a little bit. We have to go back a little bit to Cartesian coordinate system, where there is a horizontal axis and there is a vertical axis, or there is an x-axis and there is a y-axis. Now, in order for Flutter to know exactly where to start drawing the line from and where to end drawing the line, it is giving us a particular coordinate system, this particular pixel coordinate system. That basically we can say, okay, we want to start from 200 pixels to the right, 20 pixels to the bottom, and I'm going to show you what that looks like now. So let's say we want to start from 20 pixels to the right, that is 20 pixels dx, and then 20 pixels to the top. This is to the top. Okay, 20 pixels to the bottom. Let's see what this looks like. And then we want to end it at, let's say, 200 pixels to the bottom, to the right, and 200 pixels to the bottom. And let's see what this ends up looking like to us. And we have a blue line that's going from 20 here, 20 from the right of the 0, 0. So I I forgot to say this. The coordinate system that we are normally used to, I don't know, from primary school or secondary school, usually start from the bottom here, 0, 0. But for Flutter, it starts from the top. And that might be a little bit confusing at first. But you can imagine it as, say, they flip the coordinate system on the vertical plane. So 0, 0 is up here. Yes, when you add an x offset, you're going to the right. But when you add a y offset, you're going to the bottom. You're not going to the top as you normally would. So positive goes to the bottom, negative goes to the top. And as such, that's why 20, 20, we're having 20 here and 20 here. Same thing with 200, 200, we're having 200 here and 200 here. It might be a little bit confusing at first, but with time and practice, your mind will get used to or accustomed to that this coordinate system. By the way, this coordinate system is what is being used all across Flutter, from custom painting to having custom clippers to dealing with scrolling offsets to dealing with gesture manipulation. So it's used like that all over Flutter, and so you don't have to be worried that things are going to change somewhere. This is the standard, and I advise you try to get used to it as much as possible by practice. Okay, so we successfully drawn a slanty line from 20, 20 to 200, 200, and let's push that aside and move on to the next shape. So this is how to draw a line. Now, probably I should explain a little bit of what is going on. What you can see here is this. We are telling our canvas that, hey, I want to draw a line that starts from 20, 20 and ends at 200, 200. And we give it to that and we say, okay, while I'm drawing this line, I want to see this line using this paint. This is our paint decorator. So basically, we are passing our configuration and we're passing in our decorator. So what we would like to bring our configuration to life. And when Canvas takes that in, it says, okay, this is all well and good. I think I can work with that. And then it works with that and paints this to our canvas. Then we can see our 200, 20, 20 to 200, 200 line. So I hope you guys are still with me. Let's move on to the next shape. Now, the next shape we're going to paint is a circle. Circles can be a bit confusing due to the different nature of which you can actually draw a circle. So let's. I thought I disabled Copilot. Sorry, one sec. Let me just look at it now. Okay, so let's try drawing a circle. And here we have something relatively similar going on. We want to tell our canvas that we're telling our canvas that we would like to see a circle on it. And then the canvas is telling us, okay, I need a configuration, I need a decoration for me to bring the configuration to life. Now, what is the configuration that you would like to give me? Like, how do you want your circles to look like? And so, what our canvas needs for that this circle that we want to draw to come to life is that you need the center of the circle. This is an offset, and it also needs the radius of the circle. And so this is all that our canvas needs. And mathematically, it's kind of old well, but I'm trying not to go into the mathematical details of all of this plays out, because one, I think is not really necessary, and two, it's something that you can always explore on your own, so this doesn't get boring. But this is basically extracted from the equation of the circle. If you are interested in really manipulating circles, you can go look into that, study it again. Go back to secondary school. Yeah, Potter will humble you like that. So let's say that we want our circle to start from this center, this same where this line ends, 200, because it's the center of our size. Since we set this guy to 400, so half of it is 200, which is the center. So we're going to set that, and we're going to set the radius to let's make it 100, right? And let's see what happens. Wow. Okay, we have a circle. This is like a lollipop or a table tennis bat in a way. I don't know. Yeah. So with that, we have done a circle. Now, in order to make this to not fill, we can manipulate that using our paint. And we set our painting style to stroke. And yeah, so there are different ways. Like I said earlier, this paint brings life to our configuration. So what we're telling Canvas is we want to draw a circle. Our configuration is not going to tell the canvas that, oh, I want my circle to be filled or not. That's not a configuration, that's a decoration. And so whatever it is you want to do, you can always come to paint to do it, as long as it relates to decoration or bringing life to your configuration or the numbers that you pass into the canvas. So there are other things that we can do. We can set a blend mode, we can set a color filter, and I would strongly encourage you to look into all of these things yourself, because they pass the scope of this particular lesson. Now, why am I encouraging you to look into them on your own? For the vast majority of what you might work on, you might not need all of these things for a while. For example, I haven't used inverse colors before. I don't think I've used anti-alias before. I've only used shader on one occasion, and so it's like not very common for you to use them, but it is so important for you to know what they do, so that you can always know that, okay, this is that this company is telling me to do, this is how I can do it. And that is very, very important. It's also very, very powerful. Great. So this is how to draw a circle. This is what one of the tools provided by the canvas for us to explore. Let's move on to the next basic shape, which is a rectangle. So we're going to do the same thing called canvas.draw rect. And so if you notice, when I did canvas.draw rect, there are some other options that are showing, like canvas.draw rect, canvas.draw image rect, this DDR rect. So a R rect is actually a rounded rectangle. You can look into that on your own. Image rect is a rectangle for an image. A DR rect, I don't know what that is. I haven't used it before. So you're welcome to explore it. Right, let's even see. You're welcome to explore it on your own and see what is going on inside there. But for now, let's proceed with drawing our rectangle. Now, again, the exact same thing applies. Canvas wants to draw a rectangle, wants to draw something to the screen, and it's telling us, hey, I need a configuration and I need a way to bring that configuration to life. It's like skeleton and needing flesh, basically. So what draw rect requires is a rect, and a rect is a configuration object provided by Flutter that gives us ability to be able to do many different things outside the scope of just custom painting alone. Rect is used in defining sizes in render objects. It's also used in defining sizes in stuff like scrolling, also gesture manipulation also. So it's important that you kind of like know a couple of these configuration objects, like offset is a configuration object. Rect also is a configuration object. So now we're going to construct our rect from the points that we we would like to draw a rectangle from. So let's start. Let's explore all of these different methods. There are a couple of them here that we're seeing. There is the drawing a rect from the left, top, right, and bottom. That's this LTRB. If you've played around with padding, you see padding dots from LTRB. This is something very, very similar. We can draw a rect from a center. We can draw a rect from a circle, and we can draw a rectangle from a left, top, width, and height. So those are different configurations for the different applications that we would have. It's not every single time that we want to use from points. It's not every single time that we would know the points that we want to draw a rectangle from. Sometimes we don't know it, and sometimes what we know is the left, the top, the right, and the bottom. Sometimes we only have a center and a width and the height of the rectangle, and we want to draw a rectangle from there. So if you notice, for a very, very important case scenario, this center from center, what Canvas requires in our configuration are two things. It requires the position, where to start from, and it requires how much to go. So it's like it requires where to start from and not necessarily where to go to, but how far to go from where to start from. So we are using our from point. We can do something very, very similar to this, our draw line. Let me just copy and paste this code here. So our point A is going to be the top left corner of the rectangle, and our point B is going to be the bottom right corner of the rectangle. Let's just watch it and see that. And that's what we have here. So, excuse me, from point A, we have 20,20. We're starting from the top left corner, and we go to 200,200, the bottom right corner. That's A and B. Now, if we were to do that again using the center, using rect from center, from center, what we're going to have to provide is three things. We need to provide where the canvas is going to start from to know, okay, where am I drawing this rectangle from? And that center is, let's say we want to call it the center of the circle that we had earlier, right? And then we can set it a width of 100 and a height of 100. And with that, we have another rectangle. Now, this is very, very, very interesting. I think it's interesting because we have so many different ways to do one single thing, right? There are more other methods that I would also recommend that you explore on your own. And one of the reasons why I'm telling you to explore them on your own is because it will really, really enhance how you're learning. Because by way of exploring it on your own, you would most definitely make mistakes, and you would definitely learn from those mistakes. And when you make mistakes and you learn from them, whatever it is that you learn will stay in your head more than if someone taught you by what I'm doing right now. But still, this lesson is important, right? Going further on your own takes it to a whole other level. So rectangle from center is actually a very, very, very important method for drawing rectangles. Usually for me personally, the one I use the most is from point and from center. That's the reason why I'm showing them this example. From points is by far the most famously used for me, and then because I usually would know the top left and the bottom right corner of what I'm trying to draw, and every other thing is not really as used, but it is equally. Okay, so I think I just got. Oh, we have 15 minutes. Let me see if I can quickly round this up. There's not really much to go further. The next.
So I'll create a new link. And for that, you can continue. Once it's 5 minutes, I'll drop the new link here.
Okay. Now, the next shape I'm going to cover is not really a shape. Now, the two basic shapes that we have is line, we have circle, and we have rectangle. Now with just line alone, we can create so many things. Let's see if we can draw a rectangle. Sorry, a triangle. Let's try to draw it. Let's do something fun. Let's try to draw a triangle. Right now. So to draw a triangle, we need one slanting side, another slanting side in opposite angle, and then a base. So I think let's first of all draw our base, right? I'm doing this to show how powerful a couple of these tools are. Like, for example, drawing a line. So our base is going to be a flat line that is on the exact same vertical plane. So the y is going to be the same for our first offset and our second offset. That is our point A and point B. So this is the x, right? Yeah, this is the x. So let's start from let's say 300 to the bottom. I'm sorry. Let's start from this is the x. So let's start from 100 to the right, and then let's end it at 300 to the right, and then let's keep it at far down in the angle 300 and 300. So let's see what this looks like. And yeah, so we have a base that is 100 from the bottom, 100 from the right, 100 from the left. Okay, great. Now let's try to draw the slanted side on the left. So let's call that our left slant side. And then so now what is required is that this thing has to, I would like it to meet at the center. So I don't want a how do you call it, isosceles triangle. I think I would like I don't want a scalene triangle, I want an isosceles triangle, or at least basically one of the angles should be consistent. So what I would like is that this line is going to meet at the center of our base. So to do that, the center of our base is going to be obviously, or maybe not so obviously, it is 200 from the right, and then 200 from the left. So we're going to make it 200 in the x, and then we're going to, let's see if we can raise that line to be as high as let's say 200 from the top. Okay, so just keep things simple. So our point A, we can set our point A to be anything, and notice the order doesn't have to be I think the order doesn't really matter. Yeah, the order doesn't really matter. All that is required is a 1 point and the other point. But it is for consistency reason, you should go from the top to bottom, left to right. Top to bottom, left to right. So following that, we're going to have our top side of our line as that is this guy that's going to be here. From the top is 200, so and from the right is going to be 200 also. So we'll set this guy to 200, 200, and then at the base we're going to set it to the start offset of this baseline. Yes, so let me just copy that, and what that is 100 from the left and 300 from the top, and this is what we have. Yeah, looks good enough, I guess. And then next thing we are going to do is to draw our right slanted side. So our right slanted side, all we're going to do to draw that is that we're going to start from the top 200, 200. It's still going to be exactly the same point where this guy stopped, and then it's going to end at the end of this base of this triangle, which is this guy right here, 300, 300. That's 300 from the right, 300 from the top. And then I'll just paste that here, and like magic we have drawn a rectangle, right? So this is all well and good. We can also draw more complex shapes. You can carry out this entire manipulation to draw a pentagon, to draw a dodecahedron, or any complex shape you want to draw. And yeah, so even with a rectangle, if you would like to draw a rectangle on top of this guy to make even more complex shape, you can do that. You can draw a house like this and everything. triangle and a rectangle at the bottom of it. Do whatever it is you want to do. Be artistic. So now those are the basic shapes, and I would like to now take us to the next complex shape, or other complex next level in complexity, and that would be arcs before path. So what is an arc? I don't remember from mathematics. It's just something that curves from one point to another. So an arc is a curve, like a segment or a part of a triangle. A part of a circle. And in order for us to draw an arc, let's see what configuration our canvas requires. We need a rect, we need a start angle, we need a sweep angle, and we need a U center, we need a bit. See what I said, it's a bit a level higher in complexity. All right, so let's dissect this. What is our canvas telling us? It's telling us that again we need a configuration. It needs a configuration, and it needs a decorator or something to bring this configuration to life. What is this configuration that it requires? It requires a rect that will define the region that this arc is going to occupy. So remember, we add a rect dot from center and a rect dot from point. Well, I think this would be a very good case to use a rect dot from center, since the rect dot from point might be very obvious. So a rect dot from center would require us to provide a center offset. Let's provide our center offset as the center of our rectangle, 200, 200. Let's have the width to be 200, right? Yeah, and let's have the height to be 200 to keep things simple. And so next, it needs a start angle. Now, what is the start angle? Start angle is the point where the arc starts to draw from, starts to curve from, and you can try to imagine a pipe that bends, right? Like a right angle bending pipe. At first, you have a line that goes straight, and then the line begins to curve, and then it forms a right angle, and then it continues going straight again to supply water to the rest of the house or whatever the pipe is supplying. Now, that curve has a start angle. For simplicity's sake, let's use 0. Right, so it starts from angle 0, and then it sweeps a distance. I'm going to need a math library right now. And I'm going to call it math. And so it's going to sweep a mass of pi over 2. Now this is 180 degrees. So we're going to sweep 180 degrees, and let's set U center. True, do you want to use center? I think you want to use center. And ta-da! Oh, pi over 2 is 90 degrees. Sorry, I forgot some mathematics. Right. So with this, we've been able to draw a rectangle. Sorry, an arc. Now, okay, we're just seeing what U center happens to create. What U center is doing is that it is extending our decorator to actually go into the center and draw like this, beautiful arc. This beautiful right angle here. So let's remove this from now. Let us call it false, since what we're actually drawing is this arc, this curve right here. So this is what the arc is. We are starting from. We are having a center offset at 200, 200, which is the center here. Let me bring this guy back for reference. Okay, so this is our center here, and then we're starting from 0 angle, and we're going in the counterclockwise direction, which is quite interesting. Let's see what happens when we make this negative. Right, it goes in the clockwise direction. Wait, sorry, it goes in the this is the counterclockwise direction, and this is the clockwise direction. So counterclockwise, clockwise, and it's when the angle is positive, it will always go in the clockwise direction. Now let's try to do something slightly fancier. Let's start the angle from somewhere different. Let's say a bit to this right here. I think that should be divided by 3. Over 3. Okay. The amazing magic with it. Just like we're doing with paint, we're going to do with path. And with path, we can do stuff like path.draw.line2. And we can do stuff like arc2. We can do stuff like quadratic bezier 2, etc., etc., etc. So what path is doing is that it's taking, okay, I want to draw something very, very, very complex, but I don't want to rack my head around creating a different shape, creating a different configuration. It is similar to drawing with your pen on your paper, and you're saying, okay, I don't want to remove my pen. I don't want to remove my pen from the paper. I just want to draw something in a single sweep. How can I draw in that single sweep? So imagine you wanted to draw this rectangle with this 180-degree arc, right? Without these edges here. How will we do that? Right? Normally you would think, okay, let me draw a rectangle, and I'll now erase the bottom line here, and I'll now draw an arc. And that's not going to be very possible using basic shapes. So with path, we're able to do something very, very magical, which is being able to draw stuff on the screen relative to the previous point that we were in. So you notice that when you're drawing with your hand, you're trying to drag stuff along the screen, along your paper. The next place that you're in is relative to the previous place that you were in before. So next, if you draw an arc, and you want to draw let's say we draw this arc, and we want to draw a rectangle. Next line that we're drawing is not based on our start offset. It's based on the place that we are in now. Then we now draw a line relative to, that's why we are saying line 2. So we draw line 2, the next place that we're in. It is so the start offset, we don't need to provide it since it already knows where it was before. And then next time we want to draw on that line, it already knows where it's starting from. So all it doesn't tell it is where it is going to. Same thing with an arc, it already knows where it's starting from. So the arc to here, we are providing the size of it and then the angle. And so what it is doing is that, okay, it already knows where it's starting to. It's just deciding to know, okay, where am I going to next? How am I going there? And so this embodies fully what configuration is in the idea that I gave of canvas requiring two things, which are the configuration and the decorator. And for us to draw path on our canvas, we're basically telling our canvas to draw path based quite obviously, quite intuitively also. So draw the configuration that I just made with the decorator that I just created here. And so let's do something quite fun. So let's start from somewhere. Let's move our path. So when you're doing path.move to is basically saying, okay, I'm going to move to this point, but there's not going to be any line created. So you're just moving there without drawing anything on the screen. So let's move to 20,20, just like we did before with our first line. And then let's draw a line to 200, 200. And we can do this in one go using the optional chaining, the chaining operator. This is dot dot. In that, and ta-da, we have a line, just like we did with line earlier on with the canvas or draw line rather. Except now we can go further. We can say, okay, let me draw another line. I want to drop it to the bottom of the screen, which is 400, 400, and I'm going to put at the center, and this is 200. And just like that, we're able to create this relatively boring shape. And we can take it further. We can say, okay, let me draw another Y. So in order to draw another Y, let me show you something to elaborate more on this move to. I'm going to move back to the center that I was in before without drawing any line. This is the center that I was in before, so I just put that. And notice that nothing happens. I just moved to the center, nothing happens. Not drawing anything, but the moment I come back and say, okay, let me move to, so this is this other 20 here, but here, so that is going to be 400 minus 20, and that is 380. So now the x is going to be 380 and now the y is going to be 20. So do that, and okay, sorry, this is supposed to be the line, so do that and we have our line like that. So you can do but I think you can probably imagine the amount of complex manipulations that you can actually do with path. You can draw a circle, we can complete this triangle here, we can jump here and draw whatever squiggly shape we want to, or whatever liney shape we want to, like angles. You can create angles from point to point, point to point, and do whatever it is we want to with path. So it's very, 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 very customizable. Is the reason why I use it the vast majority of the time. I use path, and although for lots of simple cases, drawing shapes works perfectly, and sometimes you don't really have to go through the overhead of having to do some things with path. But I think the next step in complexity is just knowing and understanding path and how to manipulate path. And so let's try to move on to some very beautiful utilities in path. I'm not going to go into too much detail in this. I'm just going to talk about a few, which is, okay, let's see how we can draw a rectangle using path. Okay, so let's see, does path have a rect? So no, it doesn't. So we're going to use this particular line and moving and lining and moving to see what we can do. Okay, so let's move to 20,20, right? Let's actually by again. Path move to 20,20. No line is drawn, absolutely nothing. That's exactly what we want. And then let's draw the top part of our rectangle, right? This part. So remember, okay, let's start from top to bottom. I remember I mentioned top to bottom, left to right, right? So top to bottom first. So let's do that. Let's say line to and okay, let's keep it simple. Let's call it this 100 so that I don't do complex mathematics. Let's move to 100, 100, which that will be somewhere around here. And then this line to the x 100 and the y 300. So that's going to be 300 to the bottom. And what do we have? We have exactly what we wanted, line to the bottom. And then we're going to do it again and do our line to the right, which is going to be 300 to the right. So we're making it a equilateral rectangle. That's a square. So let's call our x 300 and our y also 300, so it's still 300 to the bottom, and we have that. And then to go up again, we do the exact same thing. We'll go line from 300 at the bottom to 300 to the top. So we go our y will be 100. So since it's still 300 from the right, so it's still exactly going to be the same. And then again, we go now 100 to 100, exactly where we were before. And ta-da, we have a rectangle. And we can actually fill this, I think. Yes, we can fill this. If this wasn't complete, it would still fill. Oh, it's one. But yeah, we can actually fill this since it's a complete closed shape. And that's the beauty of path. Once it's closed, you can fill it or not. So whatever decoration you want to do, you can do the manipulation you want. But let's just set it back to stroke for learning purposes. Also, you can increase the stroke width if you want to. Yeah. Now, let's do something even more interesting. Let's take this up a notch. This is getting very sweet. Let's try to draw an arc. Okay. So what would an arc look like? Let's leave this path here. I'm going to come back to this. Let's call it our line path. And let's call it our line thing. I don't want to remove this from the screen. This and then create another paint. And set a stroke width. Look at this. Stroke width 2, just as we had before. Color, let's put it 2. Sorry. It's red. Okay, and then we create our pins. Arc pins. Oh, sorry, arc path. Call it arc pins. Then I can now do this. And okay, let's start defining our path. Okay, so let's do this again. Let's move to the center of the rectangle. Sorry, of the canvas. And then let's call arc 2. Okay, great. So what is the size that we want our rect to be? I think I would like it to be let's do from center. Let's make this center. And then let's make this 200 sides 200. And then start angle 0, just as we had before. Sweep angle pi. Okay, let's remove math. Math of pi over 2. Force move to. Do I need to force it? No, I don't need to force it. And let's see. Just exactly as we had before, we have again an arc. Okay. Let's see what happens if we actually move. Interesting. Now, let me first of all give an overview of what's going on here. Just exactly as we had the arc. Now, if all we wanted to do was to draw this arc, right, it would be significantly easier or better, more advisable for us to just do canvas.draw arc rather than creating a variable and then having to set that variable, right? It's exactly the same thing that's going on under the hood, right? But if all we wanted to do was to draw this arc, best to use canvas.draw arc. But because we want to cite a path example, we are doing this with path. You notice it looks almost exactly the same thing with what we had with draw arc before. Now, why do we have this first move to? Okay, so this first move to is quite useful when you are dealing with I don't know if I can give an example of this. If you're dealing with something where you are having, let's say, negative angle, and your point is not very, very, very consistent. It's not a perfect circle. So, to set an example, to go back to that pipe analogy, let's say you have a pipe that's at a right angle, 90 degrees to each other, but the curve, right? It's a bent pipe. and then for some reason, let's say the first leg or the first arm of the pipe is weaker than the second arm of the pipe. So the curve from the first arm of the pipe to the second arm of the pipe is not very, very, very smooth. It doesn't go like a perfect arc like this. Maybe there's a little bit of a curve somewhere. Um, First two does that allows us to do the manipulation of actually like letting it move to that point with that curve. It's like, okay, what we are providing to you will not be enough to go from where you are from to where you're going to. I would like you to fill in the gap as much as you can to help me out. So um I would advise you to, while you're exploring this, please do explore it, by the way. While you're exploring this, look into that and see how you can manipulate that value to get what you're looking for. Okay. So now yes, the next, what happened here? So what's happening here is that we moved to 200, 200, and then we are saying arc to this point from here. So remember I said in path everything is relative, like you're drawing but your hand is not leaving the paper. So we are saying move to this point, that is where our pen touches the paper, and then now I want to draw an arc from this. After moving to this point, I want to draw an arc of size 200 and 200, and I'm going to draw it. So I'm defining the size 200, 200. And the next thing I'm going to do is that I'm going to define the angle where it is coming from. So you may be wondering, okay, since I've moved to this point and my pen is not leaving the paper, what I'm supposed to do is to just draw an arc from here, right, and then reach here. But that's not the case, since we're telling it starts from angle 0. And angle 0 is here. So this start angle matters a whole lot. And if we told you to start from angle, let's say a different angle higher up here, let me see if I can get that. It's going to do the opposite. It's going to go up and it's going to draw a sweep. Yeah, it's going to go to that start angle and it's going to draw a sweep down. And so there we have it. So its path, we can actually draw this arc, and it goes from where we put our pen down, where we moved to, and then it goes to the start angle straight, and it draws the arc, sweeps down that angle. If you don't want this, you can always just remove the move tool, and we get what we're looking for. And the last thing I'm going to do is to illustrate how we can draw in this rectangle that we drew here to this arc to create something like a dome. Yes, so what next we are going to do is to draw a dome, which I think is going to be very, very, very exciting. So how are we going to do this? Now, we can do it let's do it the simple way. We're going to have a separate path for arc, and we're going to have a separate path for line. And to do that, what I'm going to do is just very, 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 very simple. I'm going to try to get our angle to start from here and then go the opposite direction. Let me even set it to 0. Set it to 0 and go to negative pi. And that's negative 180 degrees. And we have our dome. And I cannot come to line and I manipulate this guy to only start from the center. This is one way to do it. Right, so instead of me moving to 100, 100, I'm going to move to 200, which is this center here. I'm going to move to vertically 200 down, rather. So we're saying this is 100, this is 100. We want to move here. So 200 down, still in the same X-plane, still 100 from the left. So move to 100, 200, and then with that we have that, and then we go down to this guy here, and that's what we have here, and then So let's remove this. This top is no longer useful to us. And then from here, we're going to go up to 200 again. So what are we doing here? All we're doing here is that we are drawing our line its path. It is not a closed path. If I set this to fill, it's not going to fill properly. It's only going to fill this bottom part here. So it's not a closed dome. But basically, this is just a first illustration of what we can do with paths, with two different paths. We are drawing a line, we're moving to the start point of what we're looking for, which is the center vertically, 100 from the left, drawing 100 down, drawing 200 to the right, drawing 100 to the top. That's what we're doing here. And then let me just set this color to blue so it will look at this plateau. We have a dome. In order to do this, a separate, better way, what we can do is to merge this arc paint. So what I'm going to do is to remove this guy and then play around with the values to get what I'm looking for. Yeah, I'm going to come to that in a bit. Let's just paste this here and oh no. And tada, we have exactly the same thing. So what we're doing here is this. Now we have defined the size of our rect. Remember, the size of our rect is width, and the width of it is 200, the height is 200. So 200 to 200 is basically from here to here. And remember what I said earlier, the arc is drawn such that it's fitting inside that rectangle. That's the rectangle defines the size of it. So since the size of this rectangle is exactly the same thing as this small rectangle that we drew earlier, we can easily draw an arc sweeping 0 to 180 degrees that is going to cut across it exactly the way we want to. So simply copying and pasting the arc from the other part that we had before worked perfectly fine. Now you notice that when I come here and I say fill, it fills the entire dome. So this is going to be this is going to be the last example that I will show to us. And yeah, there are a couple of other things that you can do with Canvas. You can actually paint a text using text painter, right? I'm not going to go into too much detail as to how it works, but you can have a text painter, and this is another text painter called text painter, and we provide our text span. This is just me showing you a sneak peek into what you're capable of doing using CustomPaint. Making sure I am a Nigerian, but Tinubu is making me suffer. And T-Pain is making me suffer. And I'm going to put in a style. Okay, you can actually put in a style if you want to. I'm not going to put in a style. And I'm going to set a text direction. The text direction is very, very important. So if you don't provide a text direction, there's going to be an error. Text direction, left to right. And then I can just draw canvas dot draw. And then passing text painter. Okay. Oh yeah, sorry. Passing the canvas. We're actually using text painter to paint on the canvas, not the other way around. And then I'm going to enter the offset. What's the offset? What do I want to stay? Okay, let's say I want the text to stay at the top here. So I'm going to want to start at, let's say 100 to the right, 50 to the bottom. And okay. Okay, let's just create a text and put the color to this thing. I hope this works the way it's supposed to. Okay, this is quite interesting. So the idea is that we're able to actually draw text with our custom paint on the canvas. Should be free, I'm sorry. For some reason it's not showing. I'm going to go back and look into this as to why it's not showing. But if you have any ideas as to why it's not showing, you can drop a recommendation. But basically, ideally, there's either missing a step or something. But ideally, what we would have is that our text is going to show, and then we can actually do other manipulations to that text. We can change the font family. We can draw a shape on top of the text. And if you are manipulative enough, you can actually go into the text paint and maybe create your own custom text paint and create your own custom text family and have a text painted in your own unique way. Another thing I would like to also point out is drawing curves using Bezier. So a Bezier curve is a curve that we draw from one point to another, and we're able to define the path that it would follow. Kind of like, let's say you're drawing let's get, yes, a typical example is a bullet tip. The tip of a bullet. You notice that it's not a perfect stub like this, perfect flat head like this, or a curved head like this. It's like almost shaped like a cone. In order for us to achieve that, we cannot achieve that with a perfect circle arc. What we do to achieve that is Bezier. Now, doing curative Bezier requires a bit of mathematical manipulation, and I wouldn't like for us to go into that, but I would advise that you look into it on your own. And in order to pick your excitement a little bit, if you've ever worked with SVGs, SVGs work. SVGs are basically it's a file, it's a code file. One of the things that make them very, very lightweight is the fact that they actually code files that have a custom XML configuration for paths. So the SVG library in Flutter, what it does is that it reads that XML path that is in the SVG configuration, the SVG that you normally export from Figma, and then it converts that into CustomPaint code, and then we paint that on the screen. So just to show you how far you can actually go with CustomPaint, SVGs are actually drawn in Flutter using CustomPaint. So that's that for today's session. Our text painter did not paint the way it was supposed to, but remove. I think maybe it's this tip in here that is vexing for us. But yeah, if you have any question, please ask now, and I will answer to the best of my ability. Yes, Samuel, please go ahead and ask.
Okay, thank you very much for this tutorial. So I've actually been wondering, because from what I've seen you done, I actually want to create something myself. So I don't know if it's actually possible to put a widget inside of this custom paint. Just like I see the way you are writing a text painter. I don't know if it's possible to like do a widget so you can put anything dynamically into it.
Okay. The simple answer um, the simple answer is also no. We can't add a widget into custom paint. Um, what we can do is to come back into our custom paint configuration widget here, and then wrap that in a stack. Right, wrap it in a stack, and then now put our widget on top of it if we want to. And this actually works perfectly fine for pretty much all the configurations that you would require. But in terms of doing anything, remember I said custom paint is at the bare bone of widgets. So you have widgets, and then you go into the element, render object, and then custom paint is at the bottom there. So having a very, very abstract top level widget interact with a more bare metal custom paint is just one, is unnecessary. So what you want to do is to look at your use case. What are you looking for? There is a particular, let me see if I can still find it on my pocket. There is a particular package that I think makes it very, very complete to use custom paint. And what that package does is that it provides you the ability to add touch to custom paint. So it's kind of like, if you remember, if you're working with TextSpan, TextSpan, you have a list of inline spans that you can add here. And if you did not know, maybe this would be a tip to you. One of the things that you can do with TextSpan is that you can add a widget to it. You can add a widget span. It took me a while to actually find this in Flutter, but one thing you can do is add a widget span and then now add your container widget to a text. So if you're having something like a text, a message, users are typing message to each other on like a chat screen, and then you want the formatting to put like a custom sticker, a custom image inside that message that's been sent. This is a very, very beautiful way to use it and still be able to align center, align right, align left for your text. Now, where I'm going to is this. With TextSpan, one of the things that you can do is to provide a recognizer and add gestures to it. And I think this is one, you may not need to know this now, but being able to add a, let's say, tap gesture recognizer, and then you can just add it on top like this, is something that has brought quite a lot of people to be able to do that in custom paint. Let's say I have this point. A typical example is when you're working with charts. Let's say you have a pie chart and there's a bar, and you draw that bar with custom paint, and you want to have the users to be able to drag that bar up and down. How would you do that? So what this package does is that it gives the ability to draw, to interact with that. Let me see if I can get it here. Oof. Okay, so let's see. I think I would interact with Mercy to, I'm going to go search for that package. The package I used relatively recently. And so it provides tap gestures to custom paint. I think with tap gestures, or with gestures in any way, I think every single thing that you would need to do with custom paint is completed. So here's the reason why I'm saying that. Remember I said custom paint provides you the ability to do two things. You give it configuration, give it how you want to decorate it, and boom, you have what you're looking for. Literally anything that you want to do, you can do it with these two things. If you go into your widgets, what you're having is a configuration, something that defines configuration, a stack, a container, a row, and then you now give it something that requires decoration, like a text, like a custom paint, like your decorated box, etc., etc., etc. It's exactly the same way we lay out UI, except this is giving us more fine-grained control. So if you want to add a widget to it, you are better off doing two things. You're either better off drawing the configuration that you want for that widget with custom paint, or you use a stack. And if any other thing that you want to do, you can always do that with either custom paint or widgets, but not both. And I think the superpower that the only limitation that custom paint has is that it couldn't add tap gestures to it before, but somebody found a way around that and created a package for it. So that is pretty much it. Oh,
Okay, cool. Thanks very much. I understand that.
Wow.
this is what was missing. So now I just forgot something. I was supposed to explain what should repaint does, and I just okay. So let's go into it quickly before the next person that wants to ask a question, if there is any. One of the things that people really use custom paint for, aside for drawing custom complex UIs, is animation. Animation is, let's say you want to create a circle loading indicator, right? And well, material circle indicator isn't as beautiful as we want. You want to do it your own way, or the designer lost his head and decided to do something crazy, and then you have to do it. When you finish drawing the configuration for it, what should repaint does is it's like, okay, do you need this thing to repaint? Every single time that I come into this, let's say Flutter comes into custom painter, it gets the paint function, it gets the canvas, tries to paint the screen. What it's doing is that it's actually like caching that canvas, such that just like when you do with hot reload, you have to call set state to change the state of your widget, to call the build method. Same way you have to I think that's a timer. Same way you have to set should repaint to whether you would want the let's say call it this build method of your custom painter to call again. So in cases where your animation does not need to change, let's say you have a circle loading indicator and what you are using to change the orientation of it is you're using, let's say, a transform widget, transform the rotate, and then you're passing the angle, and then let's say that angle is value times whatever. Okay. So let's say that value is this times whatever. Just giving it the value times pi, for example. Now what is changing is this transform rotate widget. Your custom paint is not supposed to change. Nothing is going to happen to your custom paint. So if I came here and I set this guy to true, every single time that my rotation widget transform rotate rotates, it's going to come here and call paint again. So that canvas that is cached before is going to eliminate it and it's going to create another one. And that is very inefficient. So in cases like that, that's the reason why should repaint here is where the background is like, okay. Conversely, if I'm not using transform or rotate, I'm coming here, I'm saying that I know what I'm doing. I'm going to create an angle, right? And then I'm passing this angle into here, like this. So I don't need this guy. Let's call it value times pi. So when I'm here, I can now do my complex manipulation and let's say make this guy times angle and do whatever it is I'm looking for. It is in such a case that I can now say, okay, should the paint should be true, because every time this angle is changing, I want the paint method to be called again. So basically, this should repaint is very essential for keeping things efficient and keeping things smooth. So I hope that kind of clarifies that for you guys. And yeah, any other questions? Okay. In the absence of questions, I would leave the rest to Nelson.
So thank you very much. Thank you so much for sparing your time to share your knowledge. Thank you. So yeah, here comes the end of the class. See you guys next time. So I'll be dropping the video in the group. All right. Thank you.